Mr. Fay. How are you?
Good. How you doing?
Doing well, doing well. We're ready to get started here. Are you ready?
We are all ready on our end.
Okay, well, good afternoon, boys and girls. My name is Lyle Tavernier, and I am speaking to you live from NASA's Jet Propulsion Laboratory in Pasadena, California. And joining me today is Dr. Ashwin Vasavada. He is our Deputy Project Scientist with the Mars Science Laboratory, and he's got some things that he's going to talk to you about today. So I'm going to go ahead and turn it over to Ashwin.
Hi, everybody.
Hi.
Hello. Did any of you guys see pictures of our rover launching a month ago?
Yeah.
Yes.
All right, cool. No, that was great. We all went out to Florida and watched it go up. And I've been working on this for about 7 years. That's a long time. And so it was great to see our rover heading out to Mars, and we're gonna get there in August of this year and then start driving around. So I thought for the next few minutes I'll show you some slides and just talk a little bit about why we study Mars and then a little bit about our rover. Is that going to work?
Yeah. Sounds great.
Good. All right. So I'm going to go to the slides, and then you won't see me for a little bit, but you'll see pictures on the screen. So this is a picture of our rover, Curiosity. You've probably seen pictures of it from your teacher. The official name is called the Mars Science Laboratory because we're going to Mars, and we're doing science, and we're bringing along a laboratory with us to Mars. But the kind of nickname is called Curiosity. And a girl in Kansas named the rover for us Curiosity because she said that curiosity is what inspires her to get out of bed every morning and learn more about the world. And it's really the same for us here at JPL. We're curious about Mars and how it works and whether there may have ever been life on Mars. And so we built Curiosity to help us understand all that. The next one. So people have been looking at Mars through telescopes for a lot of years. And here are a couple of pictures. There's a guy sitting looking through a telescope in the upper left-hand part of the picture. That guy's name is Percival Lowell. And he lived about 100 years ago and was looking through telescopes at Mars and was kind of like making up stories of what he saw. And one of those stories was that there was canals with running water all over Mars because there were people living on Mars that needed water transported from the ice caps up at the poles down to the deserts where they lived. And there was a whole civilization. Now we know that's not true. There's no people living on Mars. But for a long time people thought that. And so that made Mars really interesting to people here on Earth because we thought maybe there was other humans or other intelligent people just living on the next planet over. But we sent this spacecraft on the right called Mariner 4. In 1964, we sent our very first spacecraft to go to Mars and take pictures. And we're actually thinking back then that maybe we'd see plants growing, maybe we'd even see some animals, whatever. And when we got the first pictures back, the next slide, it was really disappointing. Doesn't look like much, right? So we got these pictures back in the 1960s of Mars that showed a lot of craters on the planet that looked a lot like the moon, and it looked like Mars was pretty dead. But just a few years later, in the next one, we got some much clearer pictures of the surface of Mars, and these showed what looked like dry riverbeds. Can you kind of see how they look like riverbeds? Yeah. Yeah, it's pretty cool. So we were really excited in 1971. I was actually not here then. I was too young for that. But the people here at JPL who were studying these pictures saw the evidence of these dry riverbeds, and it actually was kind of like what Percival Lowell thought, that there are these canals on Mars. But they weren't made by people or intelligent beings. They were made by nature. So at some point in early Mars history, there was a lot of water flowing around the surface. And that got us really excited again that there might actually be life on Mars sometime. Maybe in the past, maybe even today. The next one shows a picture of when we first landed on Mars. In 1976, 2 spacecraft that NASA launched landed on Mars successfully and took some of these pictures. And it looks a lot like a desert on Earth. That was also made it pretty exciting. Mars is a very Earth-like planet. You know, there's planets that you wouldn't recognize at all if you were standing on their surface. But on Mars, if you were walking around, it actually kind of looks like if you were walking around somewhere on Earth in the desert where there's rocks around. And the next picture is, in fact, a picture of Earth. This is a picture taken if you were standing on one of the volcanoes in Hawaii. Anybody been to Hawaii? But you've seen pictures of it. And Hawaii are these volcanoes that come out of the ocean floor. And just like on Mars, where there are volcanoes also, there are these big hills with lots of rocks made out of lava. And if you go back to the other picture that we were just on, see how similar they are? And that's just because the same kind of things go on Mars as they do on Earth. Both planets have volcanoes. Both planets have lava coming out of volcanoes, and the lava breaks up into rocks, and you get a surface like this on Mars, and you get a surface like this on Earth. So Mars is really an Earth-like place. We find it we kind of feel at home in a way if we went to Mars. And someday, of course, the goal is that we will actually go to Mars. And we'll, one of the ways it's different is that we couldn't actually breathe on Mars. There's not enough oxygen like there is on Earth, so we'd have to wear spacesuits. But in other ways, it's pretty similar. We'd walk around, we'd kick around the dirt, there'd be rocks, and with some mountains to climb. And, a lot of that is what we see when we send our rovers. So let's talk a little bit about Mars. Here's Mars. It's the red planet, but in reality it's kind of more of a yellow-brown. But we'll still call it the red planet because it looks red at night if you see it as a star. And then, can you see that big line across the middle? Maybe I could point to it.
Yeah, if you bring the mouse, usually wiggle it a bit.
Oh, there you go. Can you see the mouse?
Yeah.
Okay. See this thing right here all the way across?
Yeah.
Yeah, that's a canyon, kind of like the Grand Canyon on Earth, where the surface of Mars is split open because of kind of like earthquakes, like a fault, where the whole surface of Mars split open. And if anybody's been to like a canyon around New York or even like around the southwest United States, they're pretty giant. The Grand Canyon's really big. But this canyon on Mars, if you put one end of it in San Francisco, the other end of it would go all the way to New York. So it's a huge canyon. There's nothing like that on Earth. So Mars is pretty spectacular because of some of the stuff that's on the planet's surface. Another thing that's really huge on Mars are the volcanoes. So this is a picture of a volcano called Olympus Mons. It means Mount Olympus in Latin because a lot of the things we name on Mars are in Latin. So this volcano is pretty big. And Hawaii is pretty big too. I mean, Hawaii is a big volcano. But if you were to put this volcano on the United States, it'd be as big as the state of Arizona. So it's huge. Yeah, it's a giant volcano. I think it's something like 15 miles high, much bigger than Mount Everest. It's higher than planes fly on Earth, at the top of this volcano. So it's pretty huge. And it went off a long time ago. It's not active anymore. But still, Mars is kind of different from Earth in the sense it has these giant canyons and giant volcanoes on the surface. When we were driving around Mars with the rovers that are on Mars currently, it also became sort of Earth-like again because we got this beautiful picture of Mars, the sand, just like if you're at the beach and you see some ripples in the sand, and then you look up in the sky and you see these pretty clouds. Now the difference is the sky is kind of pink on Mars because of all the orange dust in the atmosphere. But on the other hand, it looks really pretty with these clouds, just like Earth. Another way Mars is sort of like Earth is if there's ice caps at the poles. So this is the North Pole of Mars with a big ice cap made out of water. And so we know there's a lot of water on Mars, but it's not flowing in the rivers anymore. It's just frozen at the poles. So this is a few miles thick of solid ice. And if you look really closely in some of these grooves in the ice, you look and you see these layers. And that's kind of interesting because each of these ice layers may represent one winter on Mars, and they build up over time. And so if we were ever to land here and drive around these layers on Mars, we could study year by year what the weather was like on Mars. And we could sort of go back in time. This is like a book with a bunch of pages for us to study. And you'll see that with Curiosity, we're going to do sort of the same thing, except we're not going to go to ice, we're going to go to rock, layers in rock. But we'll talk about that in a little bit. Here's a picture of Mars taken from the surface. And what do you think the white stuff is? Well, I guess I have the answer on there. So it's frost. Just like on Earth, when you wake up some cold mornings and there's frost all over the lawn, on Mars it was the same thing. We landed there in 1976, And in the winter on Mars, we woke up, the lander woke up and took some pictures, and there was frost all over the ground. So that was pretty cool. It also made Mars kind of like home. The final thing I was going to tell you about Mars is that it has these giant dust storms. So here on this side is a picture of what Mars looks like normally through a telescope, and you can kind of see some of the dark sandy areas and the brighter dusty areas, and you can see kind of some clouds near the poles. But when Mars gets covered by dust in the atmosphere, when there's a giant dust storm raging, it blocks all the surface, and it becomes a lot more... we have dust storms on Earth, but they're just kind of like... they can be pretty big. They can cover a whole city or maybe blow over the ocean a little bit. But on Mars, a dust storm can start building up, and nothing ever stops it until it covers the entire planet. So that's pretty crazy. So if you're over on Mars and a dust storm started, it might cover the entire planet, and you have to wait like a month or so before the air clears out again. So Mars is a pretty interesting place. Earth-like in some ways, and pretty crazy, un-Earth-like in other ways. But the question that we ask a lot for Mars, because it resembles Earth in so many ways, was Mars ever a habitable planet? What do you guys think it would take to make Mars a habitable planet? What do you think we need to live on Mars? Yeah, how do I call on you?
I'll call on him. I'll call on him. Probably be a good
Okay.
idea. Those are also our bells ringing. You can ignore those. But Elijah, if you want to go for that question, go ahead.
Trees and water.
Okay, trees and water. That's good. Yeah, you definitely need water. Life, as we know it, every form of life on Earth requires liquid water. So that's definitely something we want to look for on Mars to see if it's habitable. What else?
Connor, what you thinking?
Oxygen.
Oxygen, good. So yeah, life needs some kind of chemicals to live off of. A lot of life on Earth uses oxygen, or some life on Earth, like plants, use carbon dioxide. So you need something like that for things to breathe.
Yeah, Zach, do you have another question?
Electricity.
Electricity. So, like an advanced civilization might need electricity to run their houses and that kind of stuff. Yeah, okay, what else would make Mars habitable?
Beta? Food?
Oh, food, okay, sure. So all life, even like little microbes and fungus and that kind of stuff, needs some kind of food to live off of. So that's exactly right. And so when we send Curiosity to figure out if Mars is a habitable planet, we look exactly for those things. We look for water, and we look for chemical food. So we look for different chemical elements that life uses, like carbon, like hydrogen, like oxygen, nitrogen, all the basic stuff that your bodies are made out of and that your bodies use to survive and operate. We want to look for that on Mars to see if Mars ever was a habitable planet. And so how do we do that? We send a rover, and that's what we'll talk about for the next few minutes. The next one, sorry. So, here's our rover. I think you've seen pictures of it. There's a lot of words on this slide, but I'll just talk about it. The Curiosity rover was built to be two different things. First of all, we can't go to Mars yet. We don't really know how to design spacecraft to go to Mars yet and to live there for a couple of years. So for now, we build robots. And the robots we build to make just like us. So they have eyes, and they have arms, and they have legs in the form of wheels. And so we build them to be virtual human beings. And so Curiosity is the same kind of thing. It has a head there with a couple eyes. It can see in 3D just like we can because it has two eyes. It has a single arm with a bunch of tools on the end of it, including a drill. And we'll talk about why we have a drill in a little bit. And it has 6 wheels, so it can kind of drive around Mars just like a geologist on Earth would walk around Mars and study rocks. We also, though, built this Curiosity rover. The reason it's so big is because, unlike the previous rovers, we built Curiosity to be a laboratory as well. So not only are we sending a virtual human being to Mars to drive around and take pictures and use its arm to do things just like a human would, we bring a whole laboratory with us. So our virtual robot, our virtual human being can go around on Mars and pick up rocks and analyze them with the laboratory that it brings along with it inside the rover itself. So the rover is so big because it has a big chemical laboratory inside of it. And the whole goal of Curiosity is to drive around, drill into rocks or scoop up soil, and then analyze those rocks and soils inside the rover to figure out if there's water and if all those chemicals that we talked about are there. And if therefore we can think that Mars may be a place that is friendly to life, a habitable place. So let's see. So let's talk about where we're going. So what do you think this is? Well, I kind of have it on the slide. It's a crater. And so you know how craters form? Craters form when big things hit planets, and they make these holes in the planets. So craters formed all over Mars in its early history when there was a bunch of stuff flying around the solar system and planets were still being formed. And so Mars is covered with craters just like the moon is. But this particular crater is interesting because it has a big mountain in the middle of it. And craters on the moon tend not to have mountains. They just are empty holes. But this one on Mars has a giant mountain, and we think that mountain is there because in the past, there was all this water flowing on Mars, and the water flowed and it carried dirt with it, just like rivers do on Earth. And at some point, it deposited this big pile of dirt inside Gale Crater. And this crater is called Gale Crater, and it's the landing site for Curiosity. And what makes this pile of dirt really interesting to us is because, as in this picture, we've cut the mountain in half, and you can see that it's made of layers. And just like we talked about with the ice cap, we think that over time, different rivers have flowed, or different air was blowing and carrying dust with it. And as time progressed, different layers of rock were deposited in this mountain. And so by studying layer by layer what this mountain's made of, we can read it like a page of books that tell us historically what happened on Mars over time. So the bottom of the mountain are the oldest layers, the oldest part of the book. And as we go higher and higher in the mountain, we get to the youngest rocks that were laid down most recently by water or air or other processes. And we can study what happened on Mars. So by driving over this mountain on Mars, we can look over a long period of time to figure out if any of those times were a place when Mars was a habitable place. So that's the plan. We're going to send the rover to Gale Crater, climb the mountain with the rover, and look at all these layers. And in each one, we're going to look for water, and we're going to look for chemicals that life uses, and figure out if Mars was ever a friendly place to life. So I'll just end with a couple pictures of the rover itself. So we took, we took about 7 years to design the rover, to figure out what it's going to do, and then to build it, and then to test it. So this picture shows the rover itself in its final testing. And all the people here at JPL testing it have to wear these bunny suits to keep everything really clean. So, and to prevent themselves from damaging the rover. So the rover was built to be super clean, so that when it gets to Mars, it can study the chemicals on Mars and not study the chemicals it took with it from dirty fingerprints on Earth. So we keep everything really clean while we're building and testing it. And then we put it all together. So here's a picture of the rover inside of its spacecraft with all the people in the bunny suits in the front posing with it. And this was kind of the team photo of all the people who built the rover for us. And then just a month ago, or not even a month ago, we launched it from Florida, and that was awesome. It was great to be there and watch it go up and hear the big roar of the engines and realize that we just sent something to another planet. And then on August 6th of this year, or next year, sorry, we'll land on Mars and begin climbing Gale Crater Mountain. So that's a lot of stuff we talked about, but for the rest of the time, I'd love to just answer any questions you have about the rover or about Mars.
Okay, well, these guys have lots of questions. Many of them were about the bunny suits, so I'm glad to address that. They've prepared a whole bunch of questions, and most of them are about the rover Curiosity itself and the landing mechanism they were particularly interested in. I would just want to address, I think I'm going to call on kids just individually. They have a few questions that they can choose from, and if you just want to give me the high sign when you feel like you're running out of time, because I'm sure these guys would ask questions all day. Probably be ready to go. So I'm going to start with Nicole Raleigh. You had a few questions there. If you want to ask one of them, that'd be great.
Yeah. How come the rover doesn't like burn up when it enters the atmosphere of Mars?
That's a good question. So maybe we can go back to that slide.
Yeah, absolutely.
Oh yeah, so on this picture, the one with the bunny suits, you see the rover in its spacecraft. And you see the how the spacecraft, the top of the spacecraft is there's a dark cover to the spacecraft. That's called a heat shield. And you probably saw in the movie that that part of the spacecraft, maybe you can go back to me. That part of the spacecraft is in the front. When you're flying through Mars' atmosphere, that heat shield takes all the heat of when you enter the atmosphere of Mars and absorbs it. The space shuttle, every time it came back to Earth, also got really hot. And the entire bottom of the space shuttle is covered with these black tiles that absorb heat. And the same material is what we use on Curiosity. We use the technology from the space shuttle to coat the surface of the spacecraft so that when we enter Mars, we protect the rover as well.
Great. Keith Hall, you had a question or two. Do you have your card with you?
Yeah, they answered it.
Oh, they've already addressed them? Okay, thanks. Treya, your questions there already addressed? Okay, you've done a good job with your presentation. Ebro.
What are the chances of the rover
What are the chances of the rover missing Mars?
Yeah, having it go missing. This was a big concern.
Oh, like after it lands?
Well, yeah.
Well, okay, I'll answer both. So, we launched it, and the first thing that happens is that we depend on the rocket to launch it in the right direction. And so we were all really nervous watching the rocket go up because for about 45 minutes after the rocket goes up, the rocket is still firing and steering towards Mars. And so that all had to go really well, and fortunately it did. So this rocket launched us right on course to Mars. So, you know, the first chance that we could have gone off course, we successfully did not go off course. And then now we're just sort of coasting towards Mars, and we have to do little maneuvers every few months to fire a couple rockets to make sure we stay on course. And we sort of refine our aim towards Mars. So each one of those is another chance for us to be able to stay on course. And the first one of those is coming up in January. And then hopefully we get to Mars right where we want to go, and we land on the surface. And then we talk to the rover every day, and it, let's see, how do I answer this? So we talk to it, and it kind of, it searches for us in the sky. So just like if you're on Earth looking up at the sky and looking at all the stars, imagine yourself on Mars, you're the rover, and you're looking up at the Martian sky, and you see all these stars, and one of those stars is kind of bluish, and it's Earth. So the rover, if it ever gets disoriented or lost, it knows how to search the sky and find Earth. And it does that by pointing its antenna and kind of scanning the sky, and until it hears us trying to signal it, and it can hone in on that. It also knows how to look for the sun. The sun's much easier to find than Earth. So the rover also can use its cameras to search the sky for the position of the sun, and then where the sun is will tell it where it is. And so it has a couple ways of making sure it doesn't get lost.
Okay, thank you. Alexis, do you want to ask a question?
How long do the pictures take to get to Earth?
Yeah, that's a good question. So at the speed of light, it takes about 10 or 15 minutes for information to get between Earth and Mars. And you can't go any faster than the speed of light. So the fastest we could ever get data from Mars is about 10 or 15 minutes. But really what happens is that the rover is pretty smart. And the best way for us to operate it is to give it a whole set of instructions every morning on Mars. So when the sun rises on Mars, at about 9 o'clock in the morning on Mars, we talk to the rover and we give it a whole day's worth of instructions. And it's smart enough to carry out those instructions. Like it'll drive over here, it'll deploy its arm, it'll drill in a rock, it'll acquire the sample and study it. And then at about 3 p.m. on Mars, about 6 hours later, it'll transmit the data back to Earth. So we get a whole bunch of data from the rover about once a day at 3 p.m., and then sometimes we talk to it also at 3 a.m. So, we'll get data from the rover about every 12 hours.
All right, thank you. Shannon Miller, you have a couple questions here. You want to ask one?
What are some of the materials that the Mars rover contains, and which ones are the hardest ones to get?
Most of the rover is made out of aluminum, because aluminum is something that is both strong and light. And so we want to, we don't want to send, we can't afford to send a huge, heavy rover to Mars made out of steel. That would take a bigger rocket and a lot more fuel. So we build a lot of stuff out of aluminum. The wheels are made out of aluminum. The body of the rover is made out of aluminum. But some parts of the rover are made out of titanium also. And titanium has other things that aluminum doesn't have. Titanium really works well if the temperature is changing a lot. So some parts of the rover are made out of titanium because we need it to be really robust to big temperature changes that we have on Mars. And then there's just a lot of fancy stuff, but it's not a whole lot of the rover. Just small pieces here and there are really, really expensive and hard to get, like some of the cameras and some of the sensors and the instruments. And so we have universities build those things for us, where they specialize in building those really special instruments. And I'm sure there's a little gold and other stuff on the rover too. There's some fun stuff.
Great. Dablock? Shannon?
How do you analyze the data you get from the rover?
Well, the rover has 10 scientific experiments on it. So it has cameras, and it has these laboratories that we talked about, and it has, a whole bunch of different kinds of cameras, actually. It has some color cameras that are like the eyes of the rover, and it has a magnifying glass camera that takes close-up pictures of rocks and soil. And then it has other fancy instruments called spectrometers, which look in detail at all the different colors of light, which tell you something about what the rocks are made out of based on what color they are. So we get a lot of different kinds of data. And people use those same instruments on Earth. So a geologist is used to going out and taking pictures of rocks or analyzing rocks with very sophisticated chemical instruments in university labs. And we send those same labs, those same experiments to Mars on this rover so that we understand and we can compare them with what we know about on Earth. So we analyze the data by getting the data from the rover and looking at it on computer screens and then comparing it with what we know about similar rocks and similar pictures on Earth.
Great. Connor Light, you had a few questions, I know. Would you like to ask one?
How do you keep in contact with the rover when it's going such a long distance?
The rover has, maybe I can use this. So I have a little model of the rover.
Yeah, I just want to bring it up a little bit higher. There you go.
There you go. I don't know how well you can see that, but there's the rover. And then there's this antenna. Maybe there's another picture. Maybe the first picture of my presentation. So the rover has two antennas. One of them, it can talk. That kind of works.
Okay.
So this antenna right here, you see that one? Yeah, that one talks to orbiters that are around Mars. So we actually have satellites that orbit around Mars above the surface. And the rover can talk to those satellites, and that's the way it can send lots of pictures and lots of data to us, because those satellites have big antennas that talk to Earth. And so the rover can use that one antenna to talk to the satellites, and the satellites talk to Earth. The rover also has a backup antenna, which it can talk directly to Earth. But because the rover's so far away and the rover's kind of small, it can't send that much data through that antenna. But we have a bunch of different ways of keeping in touch with the rover, and in case one way breaks or doesn't work for a while, we can talk to it in a different way. We actually have, I think, 3 completely separate ways of talking to the rover.
Great. Jordan Pearson, questions?
Do you plan on building something to go to other planets?
I'm sorry, could you repeat it?
Do you plan on building something to go to other planets?
Do you say we plan on?
Yeah, do you plan on building rovers to go to any other planets or anything in the solar system?
Yeah, good question. So we've built rovers on the moon, and in fact, the astronauts themselves, have driven those vehicles around the moon. For Mars, we built rovers, and this is the third generation of rovers we built for Mars. The first one was about this big, and then the second one was about the size of a golf cart, and there's two of those, and one of them still on Mars working today. And then this one is about the size of a car. And so this is the third generation for Mars. And one day, maybe we'll send rovers to other places, but other planets are kind of different. Like Jupiter and Saturn and Uranus and Neptune, there's no surface. It's just all atmosphere. It's a really thick atmosphere. So we have other ways of exploring those planets. But there are some other rocky planets like Mercury, for example, or Venus. They tend to just be really difficult because Mercury is really hot, Venus is both really hot, and the atmosphere is super thick, and it kind of would crush anything we put on it. So, in a way, Mars is an easier target to explore with these rovers. But it's also really interesting because it's probably the most Earth-like planet out there.
Do you have time for two more? You told us a half an hour, and we're starting to come up on our time. I don't want to overstay our welcome. But,
let's do two more.
All right, sounds good. We'll go with Dan Raleigh. You have a question?
What is so interesting about Mars?
I think the most interesting thing about Mars is the possibility that it could have life. Because if you remember those pictures of the channels on Mars, the riverbeds on Mars, at some point, maybe like early in Mars history, they were all full of water. And water was flowing around the surface, and the atmosphere was probably a little thicker, and it was warmer. And it was a lot. It would be hard to tell that early Mars from Earth, Earth in its early history. And so you have to wonder why we're all here on Earth, but there's no people walking around Mars. But there still could be really primitive forms of life on Mars. There could be bacteria, there could be other kinds of microbes living. And if that really were true, and if life could have developed on two different planets, and we're not the only ones in this whole universe, that's a really interesting thing for us to know as humans. And so that's one of the main reasons we explore Mars.
All right, one final question then from Ethan Feder here.
What do you have to do to get a job like yours?
Well, what's kind of neat about working at a place like this is a lot of different people contribute. So, it's mostly in the fields of science and engineering, but we need people who study math, we need people who study engineering, which means, and engineers come in different flavors. So some engineers know electronics really well, other engineers know software really well, other engineers know how to build mechanical things like wheels and motors really well. And then you have a lot of different kinds of scientists. So I'm a scientist, and I study the atmospheres of planets, but other people study the geology, the rocks. Other people study the magnetic fields and other parts of planets. And then you need people like mathematicians. So we wouldn't survive here without mathematicians because they're the ones who figure out the orbits and how to send spacecraft to Mars. So we have a lot of different kinds of people that are required to do this kind of stuff. So, if you want a job here, stick in a field that studies science, technology, engineering, mathematics, and